Hello, welcome guys to my YouTube channel Coding with Idris. Today we are going to solve the move maximum number of edges to keep graph fully traversable. In the problem statement, we have Alice and Bob. They have an undirected graph of n nodes and 3 types of edges. Type 1 can be traversed by Alice only. Type 2 can be traversed by Bob only, and type 3 can be traversed by both of them. We are given an array edges where edge I consists of the type of the connection, the vertex, the node vi and ui, representing bidirectional edge of type I between the nodes ui and vi. We are requested to find the maximum number of edges we can remove so that after removing the edges, the graph can still be fully traversed by both Alice and Bob. But the catch is the graph is fully traversed by Alice and Bob if it starts from any node and they can reach all the other nodes. If it is not possible to be traversed by Alice or Bob fully, then we return -1. Otherwise, we return the maximum number of edges we can remove. In this example, we can remove this direct edge of type 1 between 2 and 1, and also the red connection between 1 and 3 of type 1. So from 1, you can see both Alice and Bob can go to 2. From 2, both can go to 3. From 3, he can go here. They can go to 2. Then will go to 4. And Alice can go from 2 and go to 4. Bob from 3 can go to 4. So all of them can visit all of the nodes. So in the case it's not possible, it's this case. We can see Alice being on this node cannot visit 2, and also Bob being here cannot at node 3 cannot visit node 4. So from this problem statement, to solve this, we can do one thing. We can do union finding or differential set union or union find. Union find is a data structure where we group the element based on the set they belong to. For example, we can see A and B have the same having the same union. So A represents B. Let's say after one iteration, we can see representative A is A and B is B. In this case, C is representing C itself and D, and so on. This is how union set work. So repartitioning the element based on the representative. You can see A is the representative of B, C, and D. So you can see here A will be the representative of all of them. This is how union find work. So to solve this problem, we'll use that algorithm. And what will be our strategy here? We will try to find all of the required edges needed. For example, you can see this edge is needed where both Alice and Bob can traverse. This also needed too. This is needed since between 3 and 4 Bob should be able to visit 4, otherwise he cannot visit from 2. And from 2, this edge is needed since Alice needs 2. visit 4. And from here, both can visit 1. So this is not needed, this is not needed. So 1, 2, 3, 4 is needed. In total, you have 6 edges. So it will be 4 minus 6 minus 4. So the answer is 2. You can see the answer is 2. So let's dive it into the coding part. So I already wrote the code to make the video short. This is to find the maximum number of edge to remove. You can see we use union find. So this class will be used for finding the representative, and this function is to perform unions. After doing that, let's get into the main function. So in this case, we'll union them based on Alice and Bob. So union the edges based on Alice and Bob. Then we iterate through the edges. If it is 3, then it's a required edge. So we perform the union between for Alice or for Bob. So we'll add those ones needed. And for the second time, we'll check also if it is 2. The priority is first to add type 3 connection, then type 2 and type 1. So type 2 is for Bob, so we'll perform need. If it is needed, we'll add. Otherwise, there will be 0. Type 1 is for Alice, like this case, between 2 and 3 is needed. So edges required will be implemented by 1. Same thing go here. This is used for Alice, type 1. After adding all the type 3, then we check for type 1 for Alice and type 2 for Bob. Then we'll add them. So this is for checking. We can see if is connected, Alice can visit all of the node, and Bob also can visit all of the node. In return, the total number of edges we have minus the required edge that will allow both Bob and Alice to visit all of the edges, all of the nodes. So otherwise we return -1. So let's submit, run first. So the code is working fine. Let's submit. Please subscribe, share, like, and peace out. See you tomorrow.